Alrighty guys, let's go ahead and get started. So question number 1 on the study guide says how many moles of magnesium are in 45,000 atoms of magnesium. So what you're looking for is moles, and remember you always start with what you have. So you have 45,000 atoms, so that's what I'm going to write on top. 45,000 atoms over 1, and since I'm trying to get to moles, moles is going to be on the top, so 1 mole of magnesium, or Mg, right, has 6.02 times 10 to the 23rd atoms, right? Perfect, right on. You have atoms on the top, cross them off. You have atoms on the bottom, you cancel them out. Ultimately, what you're going to end up doing in this problem is you're going to divide 45,000 by 6.02 times 10 to the 23rd. So it should look something like this, over 6.02 times 10 to the 23rd. And then divide that out in your calculator, right? Now, question number 2, how many molecules are in 9 moles of glucose C6H12O6? Well, you're looking for molecules, and you start off with moles, so you always write down what you have. You have 9 moles of glucose. I'm just going to abbreviate it by saying GLU over 1. And you're trying to get to molecules, so if I have moles up here, I'm going to have moles down here. So 1 mole of glucose is equivalent to 6.02 times 10 to the 23rd molecules. Perfect. What you're going to be doing here is you're going to multiply these two numbers to get your final answer. So 9 times 6.02 times 10 to the 23rd. That'll give you how many molecules, right? You have glucose up here, glucose down here, just to check yourself. Now let's move on to number 1 in this section. So this one says, how many moles are in 65 grams of NO2? You always start with what you have, so let's check that out. I have 65 grams of NO2, and I'm trying to get to moles, right? So moles is going to be on the top, so 1 mole of NO2. Right? And then since you have grams on top, you're going to have grams on the bottoms. But let's read this portion right here, right? In 1 mole of NO2, there are, well, let's figure out. Nitrogen has an atomic mass of 14. Oxygen has an atomic mass of 16. But since you have 2 oxygens, your total molecular mass is going to be this. 16 plus 16, which is 32, plus 14, which is 46, right? Plus 14 for nitrogen, which is 46, right? And that number goes down here, 46 grams of NO2. What this is saying is, in 1 mole of NO2, there are 46 grams, right? Now what you do is you divide this number by this number to get your final answer. Your final answer is going to be in moles. Let's do the same for this one right here. So, what is the mass of 6 moles of iron oxide, right? So let's check it out. So you always start with what you have, 6 moles of FeO2 over 1, and you're trying to get to mass or grams, right? So if you have moles on the top, you're going to have moles on the bottom. 1 mole of FeO2 is equivalent to some mass, right? So let's figure that out because I don't know that off the top of my head. I know that O2 is going to be 32 because 16 plus 16 is 32, plus whatever the mass of iron is. And let me pull out my handy dandy periodic table of elements here. Let's see. Fe is going to be 55.9, so let's just say 56, all right? Bring this back to you guys here. Hopefully it's in focus. Yes, it is. So 32 plus 56, that's going to give you 88, I believe. 88. So when you do that, you multiply 6 times 88, and that's your answer, right? Perfect. All right. This is the 3-step ones. You guys ready? So how many nitrogen molecules are in 3.36 grams of N2? So you always start with what you have. You have 3.36 grams of N2 over 1, right? Since you have grams of nitrogen up here, you're going to put grams of nitrogen up here. And you can remember, you can only go from grams to moles, right? So there are, nitrogen has an atomic mass of 14. So 14 grams of N in 1 mole of N, right? Perfect. And now, if we cross off our units, we are left with moles of N, but we don't want moles of N, we want molecules. So since I have moles of N up here, I need mole of N down here. And then what goes up here is what you want. So you want molecules. In 1 mole of nitrogen, there are 6.02 times 10 to the 23rd molecules. When you do that, you're going to multiply these two on the top first and divide by 14. Let's do this one. So number 2, find the mass in grams of 2 times 10 to the 23rd molecules of F3. F is fluorine, right? I believe so. Yes, F is fluorine. So always start with what you have. You have 2.00 times 10 to the 23rd molecules. And you want to go to grams. Put it over 1. Remember, if you have molecules up here, you need molecules down here. And you can only go from moles to molecules, right? Or molecules to moles. So there are 6.02 times 10 to the 23rd molecules in 1 mole of F3, right? Now, this answer would give you moles. You don't want moles, you want mass, right? So what you do then is, since you have moles up here, you're going to need moles down here. In 1 mole of F, right, you have blank grams of F, right? So what is the molar mass of fluorine? Molar mass of fluorine, I think, is 18.99, so we're going to round it up to 19. This is saying that in 1 mole of fluorine, we have 19 grams. So what you're going to do is you're going to multiply this one times this one and divide by this, right? Perfect. All right, let's see what we got here. This one right here, same thing. I'm going to skip this one if you guys have any questions on this one. This one is the exact same thing as these other two, except you're going to do a slightly different setup for it. Let's see. Now, let's calculate the molar masses and percent composition of each of the following compounds. Show your work. Sweet. So if you have something like tricalcium phosphide, or calcium phosphide, actually it's an ionic bond. So let's do it. So first of all, what we have to do is figure out the total mass percent of all this thing right here for each individual atom, right? So we're trying to figure out what percent of this molecule is calcium, what percent of this molecule is phosphorus, right? To do that, we have to figure out the molar masses of this whole molecule and then over it by the mass of each individual compound. That's a little wordy, so let me just go ahead and show you what I mean. So first and foremost, calcium has an atomic mass of 40, right? So 40, but since there's 3 of them, we're going to multiply by 3, so we get 120, right? Phosphorus has an atomic mass of, let's see what it is here, 30.94, so that's going to be 31, since there's 2 of them, times 2, and that's going to be 62. So if I add these two together, sorry about that, if I add these two together, it equals 182, right? Now, this whole molecule has a mass of 182. Now, if I'm trying to figure out what percent is calcium, well, I do this. I do 120 over 182 times 100%, right? Perfect. So that's going to give you, what, let's see, that's probably going to be 2/3. So that's probably going to be, and I'm rounding because I don't have a calculator, sorry guys. It's probably going to be 0.66, which is the same thing as 66%, right? Now, if I'm trying to figure out the mass percent of phosphorus, well, the total phosphorus atoms or molecules in here totaled 62. So I'm going to put 62 over 182, and I'm ballparking it right here, guys, and it's going to equal 0.33, which is going to be the same thing as, once I multiply it by 100, 33%, right? There's my answer. Now, I'm going to do the exact same thing for this one. I'm not going to show you for time's sakes, but keep in mind you have this subscript here outside of the parentheses. What that means is, ultimately, I'm going to have one calcium molecule. I'm going to have 1 times 2, so I'm going to have 2 oxygen molecules, and then I'm going to have 1 times 2 hydrogen atoms. Right? So when I figure out the atomic mass, or the whole molecular mass of this entire thing, I'm going to have 1 calcium, 2 oxygen, and 2 hydrogen. In fact, I'll give you the total mass just so that way you guys don't have to calculate it. Remember, calcium has an atomic mass of 40, right? Oxygen is 16, but you have 2 of them, so it'd be 32. And then hydrogen, of course, is 1, so you have 2 of them, it's 2. So your 40 plus 32 plus 2 is going to be 84. 84 is going to be your total molar mass. And now if you want to figure out calcium, of course, you do 40 over 84. If you want to figure out oxygen, you do 32 over 84. And of course, if you want to figure out hydrogen, you do 2 over 84 as well. Convert those into percents. You're good. All right. Perfect. All right, so now let's just keep going. Why not? Just for funsies. All right. So determine the empirical formula. This should be relatively simple. You guys will be allowed to use your notes for this particular section. Remember, we only worked with 2 of them, right? We only worked with empirical and molecular formulas, right? So what I'm going to do is I'm going to give you an example of this one and an example of a molecular formula as well, right? So here we go. Remember, empirical is reducing it to the lowest common form or the reduced function, right? So determine the empirical formula of a compound containing 2.644 grams of gold and 0.476 grams of chlorine, right? Perfect. So what they already do is they tell you that you have 2 different elements, right? 2 different elements. One of them is going to have a mass of 2.644 grams of gold, which is AU. The other one is going to have a mass of 0.476 grams of Cl, right? And then what you want to do first is you want to figure out your percents and then transfer them into grams. So you can figure out what percent of each atom is comprises this whole molecule, right? So first thing I want to do is add both of these up, right? So what I'm going to do is, let's see if I can do this. So that'd be 0, carry the 1, that'd be 2, carry the 1, 5, 11, carry the 1, 1. So this whole molecule is going to be 3.120. Now I want to figure out the percent composition of each. So I'm going to do 2.644 grams of AU is over 3.120. That's your total mass, right? And then I'm also going to do something like this. I'm also going to do 0.476 grams of Cl over 3.120, because I want to try and figure out the percent for each, because that's step 1, right? Figuring out percent so you can transfer them into grams and then find out the molar masses and then divide by the least common number. Now, if you guys will pause, I'm going to actually divide this out on my screen, so sorry about that. Let's see, what do I got here? I have 2.644 divided by 3.12. 3.120. So I get 0.84. So AU is going to be 0.84, which is the same thing as 84%, which is the same thing as 84 grams of AU. And now I want to do this as well, so if you'll pardon me here. So now I'm going to do 0.476 divided by 3.12. And then I'm going to get 0.15. So 0.15, let's see, 0.15, That's going to be 15%, also 15 grams. 15 grams. Perfect. And actually, this one I'm going to round up to 85 because on the decimal, sorry, it was 0.847. So I'm going to round it to 0.85. So this is going to be actually be 85 grams. And this is going to be 15 grams of CO, which makes sense because 85 plus 15 will give you 100. Now, I have this, and that's my first step, right? In the according to your notes. The next thing I have to do is convert these to moles. So, if I have grams up here, I'm going to need grams down below. Gold, AU, has an atomic mass of, let's see if I can look over it in my periodic table, 196.9. So I'm going to round it to 197. 197 grams is in 1 mole. And then chlorine has an atomic mass. Let me just... Oh, perfect. All right. Chlorine has an atomic mass of 35.45. So I'm gonna just leave it there as 35.45. Cl 35.5 is what I'm gonna round it to. Grams, 1 mole. Right. Now what I do is I kind of divide this out here. So I'm gonna do that on the calculator again. Sorry, keep flipping back and forth. So I'm gonna have 85 divided by 197. 197. That's gonna be 0.43 equals 0.43. All right. 0.43, and then what I'm also going to do is divide this number right here as well. 15 divided by 35.5. So 15 divided by 35.5 equals that. That's going to be 0.42. 0.423, so 0.43. Actually, I'm going to round it up to 0.43. Now remember, your last step is to actually divide by the lowest common number. So, but both of these numbers are the exact same. So what I'm going to do is I'm going to divide 0.43 by 0.43 and 0.43 by 0.43, and I'm going to get 1 for both of them. So my formula is, so this is going to be, sorry about, I'm running out of space. This is going to be 1. This is going to be 1. And that's your formula. So it's going to be AU1 CL1. Or you can simply write it as AuCl. Perfect. And that's it. I'm going to go ahead and stop this video. I'm going to make another video just because I'm running out of time. I have to go to Villa to recruit. But stay tuned for the other one. It'll go over the last 3-4 problems. All right. Thank you guys.